Section 5.1, problems 1, 2, and 3. Problem 1, we've got, 5 parts. Which of the following are continuous variables and which are discrete? All right, the number of traffic fatalities per year in the state. Now, here's how I think of it. If it's countable, it's going to be discrete. If it's a measurement where you can get fractions, then it's going to be continuous. So if you can get only whole numbers, countable is going to be discrete. If you can get fractions, it'll be continuous. All right, so what about the first one? The number of traffic fatalities, all right, that's countable, right? You get 0 or 1 or 2 or 3. All right, so this is going to be discrete. What about this one? The distance, well, there it is, a distance. Now that's continuous right there. A golf ball doesn't just go 1 foot, 2 feet, 3 feet, 4 feet. It goes continuously through, right? It's measurable. So this is going to be continuous. Time, all right, now in part C, this is time. Time is continuous. The time to drive home. All right, so that's going to be continuous. D, the number of ships in Pearl Harbor on any given day. Well, it's the number, it's a count. That's going to be discrete. And E, your weight. All right, well, weight is a continuous. It's a measurement. So there's number 1. Number 2 says, consider each distribution. Determine if it's a valid distribution or not. Explain your answer. A distribution is going to be valid if 2 things happen. Both have to happen. First of all, for each x, this has to be true. 0 less than or equal to p of x less than or equal to 1, which just says that each one of these less than or equal to 1, each one of these numbers, right, each one of the p of x numbers, like each one of these numbers here, has to be between 0 and 1, right? They have to be probabilities. They have to be between 0 and 1. Well, that's not all that has to happen. The second thing that has to happen is this. If you add them up, if you add those p of x's up, you have to get exactly 1. So what we have to do is we have to verify both these conditions for problem A and problem B. Now for problem A, I'm going to say this. I make an observation, and I can observe that each one of these numbers is between 0 and 1. All right, so here's how I have to say it, though. I have to be able to convince you that I've actually looked at both of these criteria. I have to tell you that I've looked at this one and okayed it. I've looked at this one and okayed it. I can't just do this one here. So I'm going to tell you by observation. It means I've looked carefully, and I believe that for every one of these x's, okay, up here, for that x value, and that x value, these p of x's are between 0 and 1. And the second thing is this. If I add those up, if I add those p of x's up, what do we get? We get 0.20 plus 0.63 plus 0.17. That comes out to exactly 1. So now I have verified condition 1 and condition 2. But I have to make a statement now. I can't just leave it like this and like this. That doesn't tell the reader anything. I have to actually make a conclusion. So you have to actually write this sentence here. Now, if I'm just doing this for myself, I would just say, okay, that one's good, I'm good to go, and I'd move on. But if I'm presenting something, if somebody asks me a question, I have to answer it in a complete way. So I'm going to say, since both criteria are satisfied, this distribution is a valid probability distribution. You ask a question, I've given you the proof, and I've given you a conclusion. Let's move on to distribution number 2. Now, it looks like it might be okay here, right? We've got 20. Oh, I see a problem here. Okay, so first of all, this is going to be valid if, right, I have to go through the process, if 1, for each x, this is true. Now, is that true? For each one of these x's, is that first criteria true? Yeah, each one of these p of x's is between 0 and 1. So I would say, by observation, 0 less than or p of x less than 1 for each x. But now B, this is where I think it falls apart, right? B, if I can get it to right here, B says, if I just add up the p of x's, okay, if I add up these p of x's, I'm going to get 0.20 plus 0.63 plus 0.27. That adds up to 1.1, which is greater than 1. So this is not going to work, right? So I could write a sentence. Here's what I would say. Since criteria 2 whatever you want to say, fails, this distribution, get a little sloppy here, this distribution is not a valid probability distribution. Okay, I'm abbreviating a lot here. Now that's how it really should be written. I mean, legible, but you should, if somebody asks you a question, you have to respond with an appropriate answer. You have to prove it. First of all, I can't just say, no, it's not. Why not? I have to prove it. Here's my proof. And I've given you a sentence as an answer. Now, in class, all we're asked to do is this. All right, what about part A? Part A, we said it was fine. So, yes, the probabilities do sum to 1. Probabilities do not sum to 1. The probabilities sum to 1. So what does this first one say? The first one doesn't work, right? It just says, yes, it is a valid probability distribution because the probabilities do not sum to 1. That doesn't work. They do sum to 1. No, the probabilities do not sum to 1. Well, they do sum to 1, right? We proved that. No, the probabilities sum to 1. Yes, the probabilities sum to 1. This is what we want. Now, for some reason, the textbook is showing us only part A, right? This part here, right? Just that they sum to 1. They're not asking us about this. I guess that's the way they wrote the problem. So we just have to say, yeah, it is a legitimate, valid distribution because they sum to 1. So I'm going to choose that. But what about the second one? The second one, no. So the answer is no. The probability sum to 1, that doesn't work. No, the probabilities do not sum to 1. So that's the one I'm going to choose. And problem 3 says, consider this probability distribution. Now, I think it's going to be valid, right? For every x, the p of x's are, the probabilities are, the values are between 0 and 1. And if I add them up, 50 and 45 is 95 and 5 is 100. It works. It is a valid distribution. Compute the expected value and then the standard deviation. All right, we have formulas for these. To get the expected value, I just have to add up these products, x times p of x. So you just come over here, x times p of x. You just multiply and then add. So ours is going to look like this. It is going to be 0 times 0.05 plus 1 times 0.50 plus 2 times 0.45. All right, well, that's a 0. This is a 0.5. And this is a 0.9. So the expected value is 1.4. All right, so I'm going to write that in over here, 1.4. Now that's fine. We got a number. Do you know what it means? It says on the average, if this experiment were done over and over again, we would come out with a value of 1.4. For example, suppose that in class there were 100 of us, and we all do some experiment, and here's the possible answers. We could get 0, 1, or 2. 5% of us will get a 0. 50% of us will get a 1. 45% of us will get a 2. So if we all do this, we all come back and we report, what number did you get? Then you report, I got a 0, I got a 1, I got a 2. Right? If we average those up, what are we going to get? Right? We add them up, we divide by 100, we'd come out with 1.4. So if you had to make your best guess, suppose it was a game like this, and you can't win this game, but you want to minimize your losses. So for every value you're off, you have to pay some money. So guess a number between, guess one of the numbers, 0, 1, and 2. Or guess a number between 0 and 2. What's your best guess? And for every value you're off, you have to pay some money. So your best guess would be 1.4. That would minimize your losses. Now, the second part here, where it asks us to compute the standard deviation, I would like you to do this on your calculator. I'll show you how to do this. we're going to use our list. So we're going to use list 1 and list 2. So the first thing you do is you go to stat. Oh, I didn't know I was in red. All right, so you go to stat, press the stat key. Yeah, that's right, the stat key. And then you select number 1 for edit. All right, so choose number 1, edit, because we're going to put in some numbers. So you choose number 1, and then what you get is L1, L2, you can see L3, there's 3 others over here. We're not going to use those. Now, you may have some numbers in these lists, all right? So I'll do it like this. Maybe you have numbers here, and maybe you have numbers here. We want to get rid of those numbers. So get your cursor, move your cursor now over to list 1. Now, if you already know how to do this, just fast forward it or skip this. Get your cursor in list 1. Now, up arrow all the way to the top. So you want to highlight the L1. So the cursor's right up here, up arrow to L1, get it highlighted, press clear, and enter. And then all of this stuff goes away. All that goes away. Now, right arrow over here, up arrow to the L2, and press clear and enter. You have to be right on that L2. Press clear and enter, and then all that data goes away. We'll see if I can clear it out here. Right, so now you have clear. What you're going to do is put your data in. Now, our data, we don't have much, right? In L1, so cursor over to L1, you're going to put a 0, enter, 1, enter, 2, enter. Arrow over to L2. You're going to put in 0.05, enter, 0.5, put in 50 if you like, enter, 0.45. Enter. Make sure you press enter. Now, go back to the stat key. So press stat again, and now just right arrow over to calc, because we're now ready to calculate. All right, so stat, calc. Now, when you do that, what comes up? Oh, now you want one variable stats. All right, so this is number 1, one variable statistics. Or just one variable stats. All right, so you press that key. What you get is this. You get list, then you get list frequency, then you get calculate. Now, the list is going to be L1, right? So you want to get L1. So how do you get that L1? To get that L1, press second, the blue key at the top left, press second, and then down here, press the numerical key 1, because you see right on that 1 key, you see an L1 above it, list 1, all right? So second, 1, and it will pop that left, it will put that L1 right in there. All right, now enter, so press enter. Now you're down here, and here you want L2. All right, so now you're going to put L2. How do you get it? You press second, and the numerical key 2, because right above the 2 is L2. So now you should have L1, L2. Now enter, get yourself to calculate, and press enter. Now what comes up? I'll do it over here on the bottom left. You see this X bar? That's the expected value, right? That turns out to be expected value of X, and it's 1.4, right? So we did it by hand. The calculator does it for us. But now you also want, all right, we have to be careful here. There's an S sub X, and then there's a sigma sub X. They're both standard deviations, but this standard deviation is for a sample. This standard deviation is for the entire population, and because we have a probability distribution, we have all the values. We don't just have a sampling, we have all the values. So this is the one that we want right here. We want this one because we've got the entire population. Now my calculator shows that that is equal to 0.5830, and in fact, does yours show blank? There's just nothing there? So we want to round to 4 decimal places, so I'm getting 0.58309. So to 4 decimal places, I'm going to round that up to 1, and I'll get 0.5831. So I'll put that up here, 0.5831. 1.